Hello, Physics students. This is Miss Claire, and welcome again in our Math 6 class. I have here chapter 14. It talks about reflection and rotation. In this chapter, you will learn reflecting to the shapes, rotating shapes around a vertex, and identifying rotational symmetry. Are you familiar with reflection and rotation physics? If not, so stay tuned in this video. Okay, let's start. Look at these two children. They are in a pond. And look at what are they doing. They are looking their reflection in the water. Okay, so if we are facing a mirror or a water or a swimming pool, usually we can see our reflection, right? So how is a reflection different or the same as the actual object? What have you observed, children, when you take a look with your in the front of a mirror? So you can share your answer or whatever your observation during our class. Let's start with lesson A, reflecting to the shapes. So look at these three children. Look at their drawings. Which of these drawings is incorrect when we are going to talk about reflection? So the children are drawing reflections of some shapes. So as you can see, the boy, the one wearing jacket, he is reflecting a shape, a lightning shape, or it looks like an arrow. And also the girl, what have you observed on the drawing of the girl? And also the boy wearing a green jacket. So which of these drawings are showing reflection? Okay, I have here a drawing. This is Eddie's drawing. We are going to reflect this in a diagonal position. As you can see, children, there is a dotted line. This is what we call a line of symmetry or line or the reflection line or the mirror line. So how are we going to draw the reflection of this blue picture? Okay, this is how to do reflection, children. Look at this example. Okay, Ron is trying to add patterns to his bathroom tiles. He makes a shape and reflects it along a diagonal mirror line. So this red line here is our diagonal mirror line. So how to reflect the shape in a diagonal mirror line? Count the number of squares from each vertex of the shape to the mirror line. Example, this is our vertex, this one. Vertex means the corners of a shape. So from the mirror line, we count how many squares. From here to here, from this vertex, this is only half line or half square. So on the other side, also half here. Then from this one, from the mirror line until here, this is 1.5. So from here, 1.5 also. So we can put the vertex here, we can draw. And the same thing with here and here. From this one, this is 1.5. This is also 1.5. So same distance from the diagonal mirror line. And this vertex here up to the mirror line is half. And also here is also half. Right after that, we are just simply connect the vertex. So for this one, for each vertex in the reflection is the same distance away from the mirror line as the original shape. So if we reflect, make sure that the line from the original and your reflection from the vertex to the mirror line should be the same distance. Okay, so for step 2, count the same number of squares from the mirror line to get the reflected vertex. As what I have mentioned earlier, if you count half, this one half square, on the other side half square also. If you reflect 1 square, on the other side also is 1 square. From this vertex until here, this is 1.5. So here is also 1.5. After that, we are going to join the reflection. So we are going to join them or we are going to connect the vertex so we can form the reflected image of the original shape on the other side of the mirror line. Okay, I have here another. In Ron's bathroom, in the other bathroom, he makes a triangle and reflects it along what kind of mirror line is this? This is a diagonal mirror line. So how are we going to reflect? from this vertex, you are going to count. So this is 1.5. So on the other side, half, then 1.5. So this one, same size, so same length. From this one until here is also this one, the same length as this one. See, from here, then here, and this is also same length. So after that, simply connect this vertex here. So we can draw now the reflected image of the original shape on the other side of the diagonal mirror line. So that's how to do reflection thesis. Okay, so the lines joining the corners to their reflection are parallel to each other. They are also perpendicular to the mirror line, right? So from here until here, they are perpendicular. They can form right angle. From this line until here, it is perpendicular to the mirror line. So make sure that when you are going to draw or make the line, it should be the same distance from the original shape. Okay, let's continue for lesson B, rotating shapes around a vertex. So in this lesson, we are going to learn how to rotate a shape using one of its vertex. So look at this picture, children. Look at the boy. He has a kaleidoscope, and this is the picture that he saw inside the pattern, the shape on his kaleidoscope. Now, will the image look the same if we are going to rotate this? Okay, so if we are going to enlarge the shape, it looks like this. So will this image, children, will be the same as the original one if we are going to rotate this? So stay tuned as we discuss more about rotating shapes. Okay, take a look here. Jimin is making a card for her mother, so she wants to decorate the card using a heart shapes. She starts by rotating the heart shape 90 degrees clockwise around the black dot. This is our black dot. So if she will rotate it 90 degrees clockwise or the same direction of our clock, it will look like this. So this is the line of symmetry of the heart. When we will rotate it 90 degrees clockwise, the line of symmetry is around here. Okay, so this is how it looks like. Now, the black dot is the center of rotation. So once we rotate the shape, children, make sure that the dot will not change position or the location. It should be still the same in this location. Okay, so the angle of rotation is 90 degrees. The direction is clockwise. Okay, so if Jimin rotates it again by the same amount, what will it look like? Okay, so if Jimin will going to rotate it 90 degrees clockwise, how does the heart look like? So if you know, you can share that during our class. Okay, rotate a rectangle on a square grid at A. Take a look here. So look at the rectangle, children. The rectangle, the position is horizontal. Okay, he rotates the rectangle from this position. He rotates it, pins it on this side, the opposite side of the clockwise. So that is anti-clockwise, and that is 90 degrees. So he rotates it 90 degrees anti-clockwise. Okay. So remember that the center, this one will not change. The position or the location is still on the same location on the grid. Okay, now let's move lesson C, identifying rotational symmetry. What it means by rotational symmetry. Take a look here, children. How many more squares does EZ have to color so that the square puzzle has a line of symmetry? So this is a grid. So how many more she needs to color so she can have a line of symmetry? Okay, so let's discuss more about that. Let's go here. Okay, so what's the minimum angle do you need to rotate the square puzzle so that it looks the same again? Okay, so some objects or some shape, children, that if we will rotate them, it will still the same as the original shape. Others, when we rotate them, the shape will change, the position of the shape. Okay, for example, take a look here. Ron sees the recycle icon on a bag. He notices that the icon looks the same when he rotates it through a certain angle. Okay, look at this logo. This is the logo, right? Okay. When he rotates it like this, 120 degrees, it's still the same, right? Only the position of the letters change. But the shape, if we erase the letters on the logo, the shape is actually still the same. When he will rotate it again by 120 degrees, the same. Still, the shape still looks like from the original. This is the original shape. And he rotates again 3 times. The third time by 120 degrees is still the same. Therefore, this logo can be rotated 3 times at the same at a certain angle, which is 120 degrees, and it is still the same from the original position. Okay. So this icon or that logo, it has what we call rotational symmetry. And we rotate it 3 times, right? The same position, the same as the original. So the number of times an object looks the same in a 360 degrees turn is called the order of rotation. So that shape earlier, because when we rotate it 3 times and those 3 times is still the same from the original position, it has the order of rotation 3. It has 3 order of rotation. So the icon repeats itself 3 times when it is rotated through 360 degrees. Therefore, this icon or that logo has a rotational symmetry of order 3. Why 3? Because when we rotate that logo 3 times, those 3 times, it has the same shape, exactly the same as the original shape. Okay, can you sketch, children, of a shape without rotational symmetry? And how about quadrilaterals? Though all quadrilaterals have rotational symmetry of order 4. Now I have here some quadrilaterals. Take a look. I have here a rectangle. Let's rotate this rectangle and let's try to find out how many is the order of rotational symmetry. Take a look, children. So try to find how many rotation that it will look like this in this formation. Let's try. Take a look. So let's rotate the first one. We will not include this. So this is no. Yes, this one. So this is the first order. Next. No, because the position is different. And this one. Okay. So rectangle, children, has, yes, it has rotational symmetry of order 2. Okay. So only 2. Now, how about if we will going to rotate a square? Take a look. I have here a square, children. Okay. Okay, this one, let's try to find out how many is the order of rotational symmetry for a square. Let's try. Okay, let's rotate the square. 1 is still a square, right? Next, another 2 is still a square, the same as before. 3 and 4. Okay, therefore, a square has a rotational symmetry of order 4. So, quadrilaterals, children, not all have the rotational symmetry of order 4, only the square. The rectangle has 2. Try to find the other quadrilaterals, how many rotational symmetry or their order do they have. Okay, P6. Okay, P6, I have here a star. Can you try to rotate a star and count how many is the rotational symmetry of order or the star? Okay, if you know, share your answer during our class. And that's all about chapter 14, reflection and rotation. I hope P6 that you learned a lot in this video. Thank you for watching and always remember to stay safe and healthy. God bless everyone and enjoy the rest of the day.